How are you, fifth years? Just wanted to run through a quick introduction with regards to Surds before you give a few of these an attempt today. This is the last section on this chapter. We'll be finished this topic once you've completed the work and sent it to me today. So on Monday, I would be suggesting we do a couple of exam paper questions based around this, and then we can move on to our next topic. So Surds, as I've said there, as you can see, are numbers that can't be written as fractions very simply. So we are used to simplifying fractions or simplifying answers so that we get a whole number answer. Let's say that x is equal to -4 or y is equal to 13 or whatever it might be. And we can also usually come up with a fraction as an answer, 3/2, or b is equal to minus 4/5, whatever it might be, as simplified as possible. So we're used to writing answers like that as solutions to algebraic problems. In this case, now when we're talking about surds, we won't be giving whole number answers like that. We'll be given some kind of answer that has a root value in it. So say, for example, we'll give our answer and it could be 5√3 or something along those lines, or anything, something that looks like that. So as we said, we must leave them in root form in some instances because they can't be written as a fraction. So you can see a couple of examples there that can't be written as a fraction. Square root of 5, square root of pi. If you pop them into your calculator, they'll give you a decimal answer. They won't give you a fraction possibility as the answer. It's either square root of 5 on its own or the decimal answer, which in this case 2.24 to 2 decimal places. Or if you do square root of pi, you'll get 1.77 or whatever. Okay, so these are all given to you in this form, and you'll be expected to give answers to some of these problems, and they'll look something like this, essentially. A number multiplied by a root. Okay, so there's two rules there that we've mentioned that we can see, and all that's saying is if I have two square root values beside one another, so imagine that's the square root of 5 multiplied by the square root of 10, I can put them together to become the square root of 5 times 10, which would be the square root of 50. Nice and straightforward. Okay, alternatively, with the other ones there, you can see it there, that's going to be the square root of let's say the square root of 20 over the square root of 4, and that could become the square root of 20 over 4, which would be the square root of 5. So you can see the two of those in action there, those two laws. So that's what they look like. As I said, people get confused with the A's and B's, so I've given you numeric examples there to show you how they actually work. And again, it's just multiplication or division based around what's happening, and we move that root value around. So a couple of examples of how these work. You can see in the bottom left hand corner here, I've got my first example, square root of 100 multiplied by square root of 100. I've done it two different ways based around what you guys know about indices so far. So first and foremost, nice and simple, I can get the square root of 100 is 10. So I'll just do 10 and 10 and multiply those and get my answer. So that's nice and simple. Alternatively, what we could do is we could use our laws of indices to get a value there. So you can see what I've done. I've converted the square root of 100 to 100 to the power of a half, because they interchange from our laws of indices that you've looked at over this week. And the same here, of course, so they're just repeated by one another. And again, remember, when we've got the same base value and they're multiplying by one another, we can just add those powers. So a half plus a half gives us 1, and anything to the power of 1 is itself. Okay, so we've got 100 to the power of 1, which is 100. Nice and simple. So you can see they're both the same value, both the same answer, just two different ways of doing it. What you will be expected to be able to do, and this is the important part here in this, and this is the brand new section, I suppose, is reducing or simplifying surds. So if you're given a number like that, the square root of 32, as you can see, that's quite a big value. The idea is that we'll try and break that down or keep it as simple as possible. Same way as you wouldn't leave a fraction as 100 over 25, we'd change it to become whatever we can, which is 4 over 1 in that case, which then becomes 4. So we simplify it, we break it down to the smallest values that we can do. So you can see, as I've said here, our top tip for that, break it into roots that we can find a whole number answer for. So you guys are used to using root values on a regular basis now. I'm just going to get rid of this stuff and redo my example up here. So the one that's given to us is the square root of 32. As I said, I don't know what that is off the top of my head. I could go and have a look. I could do it in a couple of ways. Look at my factors of 32. I could do the square root of 8 by the square root of 4. That might work. So let's keep going with that then. I know the square root of 8, I don't know off the top of my head. The square root of 4 I know is 2. So I could change that to become 2 times the square root of 8. And then I would work on 8. The same again. I could have 2 by the square root of 4 times the square root of 2. Because those two things are the same, aren't they? And I break that down into 2 parts because 4 times 2 gives me 8. So then I've got that again. And I know that that becomes 2 again. So that would be 2 by the square root of 2, which becomes the 4 times the square root of 2. So that's fine. Alternatively, I could split my 32 up into another. Again, 16 times 2 gives me 32. So I could do that one. 16, square root of 16 by the square root of 2 would give me the square root of 32. Now I know what the square root of 16 is. That's 4. So that's nice and simple. And that gives me 4 times the square root of 2. You'll notice I've got the same answer for both parts. And the bit I've done over here is exactly the same as the example that's down here. It's just to show you that you can do these a couple of different ways. There's no wrong way. Here I've got 2 options, 1 or 2. And they're both correct. You can see option 1 takes a little bit longer, but you end up with the same point. So don't be worrying about that. Just take our time, use the numbers that you know that you can find your square roots to easily. So remember, our squared values are the most important ones, as I said. I'll put them up here just to make sure that we're clear. The numbers that we want to be using on a regular basis in these, we want to be using 4, 9, 16, 25, 36, and so on. Any of our squared values. What we got? 49, 64, 81, and 100. And those ones are the ones that we need to have a look at, because I know I can get the square root of all of these values nice and simply. So keep those numbers in mind, and we're going to use them then to simplify these values as best we can. Thank you very much.